So, at this example, we are going to see the effect of the temperature at the equilibrium constant. Equilibrium constant is 4.4 times to 10 to minus 31 at 298 Kelvin for the following reaction. This one here. Change in the enthalpy is 180.5 kilojoule per mole. For the reaction, evaluate the equilibrium constant at 2400 Kelvin. At a glance, keep in mind that this is a plus here, which means that the reaction is endothermic, which means that you are going to expect an equilibrium constant bigger than the one given here. The only parameter in the Le Chatelier principle discussion that change the equilibrium constant is the temperature. Don't forget this, keep in mind. Temperature change the equilibrium constant. In order to solve this kind of problems, we are going to use the Van Hoff equation, which is let's solve this equation in order to find the equilibrium constant at 2400 Kelvin. Keep two things in mind here, that the enthalpy is given in kilojoules. You're going to convert that in joules, and you know that 1 kilojoule is equal to 1000 joule, which means the conversion factor is, in this case, these two are going to simplify and gives this value here. Also keep in mind that the temperature should always be in Kelvin, because you have to look at the R, the gaseous constant, which is expressed in Kelvin, joule per mole per Kelvin. This one requires this in joule and this one in Kelvin, the temperature in Kelvin. If you run the right side equation, this value is going to be 63.8. So in order to remove this ln, or logarithm with natural base, is going to be like this: e to power 63.8, or 5.1 multiplied by 10 to 27. In order to do this kind of calculation, you have to use a scientific calculator, otherwise you cannot do it. So from here we can find we have the equilibrium constant at 25 degrees Celsius. We need the equilibrium constant at 2000 or T2 or 2400 Kelvin. So it's 2.2 to 10 to minus 3, which means compared to the equilibrium constant at 298 Kelvin, which was 4.4 times 10 to minus 31, is way bigger. This means that is reasonable, because we are moving from 298 Kelvin to 2400 Kelvin. Also is reasonable because the reaction is endothermic. Thanks for watching, guys. See you in the next video. Peace.